So today we're going to finish up the last part of section 12.5. In the last part of section 12.5, we're going to focus on finding normal probabilities. So as we're going through these examples, we are going to be talking about using some of the stuff that we've talked about in the previous couple of sections. We're going to talk about our mean, we're going to talk about our standard deviation, and then we're going to use that to find probabilities. As we're going through these problems, we're also going to be referring to a table. There is going to be a link to your table that you're going to need in your Moodle page as well. The one that I have up there isn't necessarily the exact same one that's in your book. I think actually the formatting of this one is a little bit nicer. So as we go through, that's going to be the green sheet of paper that I'm going to pull out as we're going through these problems. All right, so when we're finding normal probabilities, we're going to have a three-step process that we're going to go through. Our first step of our process is going to be to sketch the normal curve. So as we're sketching our normal curve, we're going to label our mean and we're going to label our standard deviation, and then we're going to shade in the region that we are interested in. Because as we're going through and we're thinking about these, by shading in the region, that's going to help us with our last step that we're going to do. Right? Then step 2 is going to be find the z-score. So as we're finding our z-score, we're going to take our observed value minus our mean and divide it by our standard deviation. Then we're going to take this z-score and then we are going to look up our z-score in that aforementioned table. So in that table, we are going to look up our z-score. Our z-scores, we're always going to round to 2 decimal values. And we're going to use those 2 decimal values in our table to find our corresponding z-score. If the problem that we are looking at is thinking about a less than scenario, that table that we are looking at is going to give us our probability, which is going to be our answer. So our less than scenario is our easiest case. If we are between 2 values, we're going to have to look up 2 values in our table and then subtract them. If we're looking for greater than, we're going to look up 1 value in our table, and the complement of less than is greater than. So our complement of our area in that table is going to be found by subtracting it by 1. So we're going to kind of go through this process, look at this table a little bit more closely, and then look through some step-by-step examples. Again, as we're going through these, you will see a link to the notes, and you'll also see a link to this table. So if you want to print off this table and have a copy handy, you can definitely do so as you're going through the homework problems for the rest of this section. Okay, so before we start going through this entire process, we're going to talk a little bit more about our details for step 3. Right? So what we're going to be using in these details for this last step is we are going to be using something called our standard normal model. Right? Normal referring to the shape. It is unimodal, it is symmetric. Right? Standard having to do with our z-scores. Remember, standard units had to do with our z-scores, so we're thinking about the z's that we're going to get, the values that we're going to get are connected to this idea of z-scores that we saw in the last part of section 12.5. In our standard normal model, the mean is 0 and our standard deviation is 1. So what this does is it gives us a normal curve, right, that's labeled appropriately based on how big our standard deviation is. So in your textbook, on pages 772 to 773, you are able to see a table. Again, I will also have a link to that table up in Moodle, and or as you're going through, when you're working through problems in my math lab, there might also be a link directly to that table in the problems as you're working on them. All right, so this table that I keep talking about, we need to know how to read it. And so what we're going to do is we're going to match up our numbers on our left margin with that on our top margin. So numbers along the left margin, when joined with the numbers across the top, represent z-scores. So looking at this particular table, the number value that I have circled corresponds to the z-value of 1.00. Going down the left side, moving down, we see 1.0, and then our top, notice that the first decimal point is always 0, so we're not looking at that, we're just looking at that last decimal value. So Circled value here represents the area associated to the left with 1.00. This next one would be 1.01, 1.02, 1.03, so on and so forth. So as we're working with this table, we are definitely going to be paying attention to the labeling along the left, and we're going to be paying attention to the labeling along the top. So in this next example, using the normal model with a mean of 64 inches and a standard deviation of 3 inches, suppose we were to select an adult woman from the United States at random and record her height. What is the probability of randomly selecting a woman less than 62 inches tall? Okay, so the first thing we're going to do is we're going to start off by sketching our curve. What we see here is a nice sketch of a normal curve. So we're not actually going to sketch it, we're just going to label it. Right, so our mean is 64. So we know that that's going to be the value in the middle. And we know as we move away from our mean, we're moving up or down by our standard deviation. Right? So our standard deviation is 3. So if we add 3, we get 67. That's the next value that we're going to label. We add 3 again, we get 70. Add 3 again, we get 73. Right, now if we go to the left, we're not going to add, we're going to subtract. So 64 minus 3 gives us 61. Right? Minus 3 gives us 58. Minus 3 gives us 55. Right? So we have a nice sketched normal curve that is labeled using our standard deviations. Again, whether it's given to you, whether or not you need to sketch something out, we're going to sketch it out and then use our standard deviation to label appropriately 3 standard deviations in each direction. All right, now our question says, what is the probability of randomly selecting a woman less than 62 inches tall? All right, so if we were to think about this, 62 would be right about here on our graph. So we are going to go ahead and just draw a vertical line that extends up from that value of 62. Right. This question says, what is the probability of randomly selecting a woman less than 62 inches tall? So less than means we're thinking about this area and we're going to shade this area that's to the left. All right, so using our table, right, if we're shading area to the left, that's going to correspond to the value that's in our table. Right? So in order to use this table, we first need to find our z-score. Okay? So step 2 is to find our z-score. We're going to take our observed value minus our mean divided by our standard deviation. So our observed value in question is a 62 minus our mean, which is 64, divided by 3. We're going to do the subtraction first. Right? So if you're plugging into a calculator all at once, think about these guys being in parentheses up top, right? Or do your subtraction and then do your division. Right? Negative 2 over 3 is going to give us negative 0.67. All right, so then we're going to use our table. And I have kind of a shrunken down version of our table here. Right? But we're going to slide down, and as we look at this table, we're going to go down until we can see our negative 0.6. All right, so then looking at this table, looking at our row for negative 0.6, again, it's very, very tiny on this particular table, but we're going to then move over. Our negative 0.6, our second decimal value is 7, so we move all the way over to this value that we see here. Right? So we're going to use this row, we're going to use this column heading, and this value that we see for negative 0.67 is 0.2514. So we're going to go back up to our problem, and we're going to say the area to the left of Z62 equals 0.2514. That is our value that's in the table. I will continue the next example. I'm going to pull out kind of the nicer looking table that I have printed on a green sheet, which you're also going to have a link to in Moodle, so that way you can kind of use that as you're going through these problems. Right, so the value that we get out of our table is always going to be the area to the left, and we can see that by kind of the notation that's at the top of our table. Right? So if we look at our picture, we notice that our picture is also an area that is shaded to the left. So that means that this value that we just found is the percentage or the probability that we want. So we are going to say the probability of a randomly selected woman being less than 62 inches is about 25%. Because this 0.2514 right, rounds to about 25%. In general practice for these problems, we're going to want to make sure that we write our final answer in a sentence, and then we answer the question that is being asked of us. Right, so we're going to look at another example here. We have the same setup. So we're still using a normal model with a mean of 64 inches and a standard deviation of 3 inches. Right, so our center value is still 64. We add 3 as we're going to the right. We get 67, 70, and 73. We subtract 3 as we're going to the left. We get 61, 58, and 55. Right, this time the question asks, what is the probability of randomly selecting a woman taller than 68 inches? So we're going to come in here, we're going to draw a vertical line at what appears to be 68. Taller than means we want to shade to the right. So we're going to shade in this area here to the right. All right, now that our curve is sketched and filled in, we're going to find our z-score. Right. So 68 is our observed value, minus 64, which is our mean, divided by our standard deviation, which is 3. Again, if you're typing it into the calculator all in one step, make sure you put parentheses around your numerator. Or if we subtract first, 68 minus 64 gives us 4. 4 divided by 3. Again, we're always going to round our z-score to 2 decimal values to use our table. We're going to get 1.33. So now we're going to pull out this table. And this time I have a full copy of the table that I'm going to look at. Right? So this is a two-sided document. On the first side, notice that all of our z-scores are negative. And then if we flip it over, all of our z-scores on the other side are positive. So based on whether or not you have a negative z-score or a positive z-score, you're going to want to use either the front side or the back side. And also notice that the value 0.00, which is in the bottom corner here, and the top corner here is exactly 0.5, right? Because 0 is exactly halfway through. So anything that has a negative z-score is going to be less than 50%. Anything that has a positive z-score is going to be more than 50%. Okay, so in this particular example, we just found a z-score that was 1.33. Right, so we're going to look at our table, and we're going to feel free to use a ruler to help you out. So 1.33. So here is my row that has 1.3. All right, and I'm going to go over to the right, looking at my decimal points up top. Second decimal point is 0, second decimal point of 1, second decimal point of 2, second decimal point of 3. Right, we want the one that has a second decimal point of 3. So we're going to move down here, and we see a value of 0.9082. So that's going to be the value that we're going to use for this problem. All right, so to determine our probability, right, the value that we just saw in the table, again, is our area to the left. So we're going to say area to the left of Z68 was 0.9082. Now if we look at our picture, notice that we don't have our area to the left shaded. We have our area to the right shaded. Right? Area to the left and area to the right are complements. Complements we get by subtracting from 100% or as decimals from subtracting from 1. So our area to the right of Z68 is going to be 1 minus 0.9082, which is going to give us 0.0918. So our answer, the probability of selecting a woman taller than 68 inches is about, all right, we're going to round this to the nearest percent, 9%. Right, so just pay attention as you're going through the problems of what value you're being asked to round to. All right, so we're going to work through one more example using the same normal model. So we're going to have our 64, 67, 70, 73. Working the other way, 61, 58, and 55. Right, this time we are asked, what is the probability of randomly selecting a woman between 63 and 67 inches tall? So we're going to guess here about where 63 inches would be. 67, we can draw a nice vertical line straight up from there. And then we're going to shade in our area in the center. So in this particular example, we're going to be looking for the area that's in the center, right, between these two different heights. Right, so the first thing we need to do is find our z-scores for each of these. Right, so for 63, we're going to take 63 minus our mean, which is 64, divided by our standard deviation, which is 3. Negative 1 over 3 was negative 0.33. Right? Signs do matter, so make sure as you are calculating your values, you're getting them in the correct order. It's always the observed value first. 67 minus 64 divided by 3 gives us 3 over 3. Again, we want to think about this to two decimal values, so we have 1.00. Alright, so now we're going to find our areas. So we're going to go to our table, right? And we're going to find our area to the left of Z63 and our area to the left of Z67. Okay, so Z63 is a negative 0.33. So we're going to look at our front page. We're going to go down in our table until we see our negative 0.3. We're going to go over to this column. Let's get this in here. So we're using the column that's the second decimal value is a 3 as well. We move down this column, we get an area of 0.3707. Right, then Z67, right, that gave us a z-score of 1.00. Right, so looking at our table, 1.00, right, we have 1.0, first column here, 0.8413. So 0.8413. Right. So unlike other examples that we've done so far, here we are looking for an area between. Here we have two values. So our area between, we're going to find by subtracting these values. It's always going to be your larger minus smaller. So 0.8413 minus 0.3707, which gives us 0.4706. Right. So we are going to say the probability of selecting a woman between 63 and 67 inches is about, and round this off to 47%. So we've seen three different types. We can see a less than, we can see a greater than, we can see an in between. Again, all of these require us to draw a little sketch of our normal curve, and then to find our z-score, find our area to the left in our table, and then find the answer to our problem. All right, we'll work through two more examples. These next two examples, we're going to be looking at the length of seal pups. So the normal model with a mean of 29.5 inches and a standard deviation of 1.2 inches gives us a good approximation of the distribution of Pacific Harbor seal newborn pup lengths. Suppose we were to select a seal pup at random and record its length. What is the probability that the randomly selected seal pup is shorter than 28.0 inches? So the first thing we're going to do is we're going to label our normal curve. Right, so our mean is 29.5, so we're going to start with that. Then as we move to the right, we're going to add 1.2 every time. So we get 30.7, 31.9, and 33.1. Then we're going to go back to the beginning, subtract 1.2 each time. 28.3, 27.1, 25.9. Right, this particular example says less than 28 inches. So 28 would be somewhere right around there. Less than means we're going to shade our area to the left. Right. So to find our z-score, we're going to take 28 minus 29.5 divided by our standard deviation, which is 1.2. This is going to give us negative 1.5 over 1.2, which is negative 1.25. We're going to go to our table. We're using our negative side, so we're using the front side. Okay. Negative 1.25 gives us 0.1056. So our area to the left of Z28 equals 0.1056. Looking at our picture, we have area to the left shaded in. So this value here is going to match up with our percent that we want to know. So we are going to say the probability of randomly selecting a seal pup shorter than 28 inches is about 0.1056, rounds to 11% if we were to round it to the nearest percent. Right, so area to the left, we take that value that we got out of the table and we round it off to a percentage. Again, as you're going through anything in your on my math lab, whether it's homework, whether it's mini quizzes, whether it's test questions, whether it's questions in the final, just make sure you are entering and rounding your answers correctly as you're entering them into my math lab. Okay, so this last example that we're going to look at, we have the same normal distribution. So we're going to start with our 29.5, which is our mean. Right? We have 30.7, 31.9, 33.1. Then subtracting, going in the other direction, 28.3, 27.1, and 25.9. This time we're asked, what is the probability of randomly selecting a seal pup that is between 27 and 31 inches long? Right, so 27 is going to be right around there. 31 is going to be right around there. And then we're going to shade the area then in between. All right, so this time, since we were thinking about a between problem, we're going to have two z-scores to find. Right, so we're going to find two z-scores. We're going to have two values to look up in the table, and then we're going to subtract them. All right, so for 27, we're going to take 27 minus 29.5 divided by 1.2. Negative 2.5 divided by 1.2 is going to give us negative 2.08. Then we're going to find our other one, 31 minus 29.5 divided by 1.2 gives us 1.5 divided by 1.2, which is positive 1.25. Right, now we're going to use these values to look up our corresponding probabilities in our table. All right. So our z-score for 27 is negative 2.08. So we see negative 2.0. We're going to go over until the heading of 8. So we're going to get 0.0188. So our area to the left of Z27, 0.0188, which is a value we just found from our table. Flip it over to our positive z-scores for the other side. 1.25 gives us 0.8944. So our area to the left of Z31, 0.8944. Again, here we're working with a between problem, so we're going to subtract our values. Largest minus smallest. So our area between 0.8944 minus 0.0188, 0.8756. Okay. So we will finish this off by saying the probability of randomly selecting a seal pup between 27 and 31 inches is about 9.8756, rounds to 88%. So that's going to wrap it up for section 12.5. Again, 12.5, we are looking at a bunch of different things, right? And then this last video, we finished talking about our normal probabilities.